Hello everyone and welcome to the third part of our pre-calculus review. We're going to go ahead and jump right in here to number 38, asking us to solve this inequality. And one of the things I noticed that this inequality has a cube, a square, a linear factor, and a constant. So I know that I can't just solve this. Whenever we have any linear factor, we know that our goal is to get it equal to 0 on one side. So I'm going to need to move this 4x over by subtracting it over here, and move this 12 over by subtracting it to cancel out those two things. And overall, because there's no like terms, I know this is just going to turn into a cubic function as an inequality. So x cubed plus 3x squared, I got that minus 4x minus 12, and we'll just keep it all the same, greater than 0. So I've got this set amount, and the only way we're going to solve this cubic function without using synthetic division is try grouping. So let's see if grouping is going to work for us in this problem. In the first one, I can factor out an x squared, and I've got x plus 3. And over here, I can factor out a negative 4, and I've got x plus 3 again. So it looks good. As long as we can get these two things here and here to be the same, we do have a function that is factorable by grouping. So I'm going to factor that out. We got this x squared minus 4. Don't know why my iPad keeps jumping today. And x plus 3 is greater than 0, not greater than or equal to, just greater than 0. And that x squared minus 4 is also going to factor into x plus 2, x minus 2. So I got this x plus 3 here, and that's all greater than 0. I'm going to go ahead and erase some of this stuff over here just so I have a little bit of room to work in. At this point, you want to identify the key points from this polynomial that we've just factored. So I know that negative 2 is a key point because that would make that equal 0. I know positive 2 is a key point because it would make the middle factor equal 0. And I know that the third factor would equal 0 if I use negative 3, so that's my other critical point. So when I go and put this on a number line, I've got negative 3, I've got negative 2, and I've got positive 2. And what we need to do is we need to plug in numbers and see what would happen if I plug those numbers in. In fact, all I'm really trying to figure out is whether or not this is positive or negative. That's what I need to know. I need to know if it's positive or negative in each of these sections. So I need to know if it's positive or negative here, positive or negative here, positive or negative here, and positive or negative here. So I'm just plugging in some test points. So I need something less than negative 3. I like to go with big extreme numbers because it's easier than doing all the math, right? So when I say extreme numbers, I think like negative 100. Because when I plug negative 100 into this, if I plug in negative 100 here, I know negative 100 plus 2 is a negative number. When I plug in negative 100 here, negative 100 minus 2 is a negative number. And when I plug in negative 100 here, I know that negative 100 plus 3 is a negative number. So overall, I'm multiplying a negative number by a negative number by a negative number. I don't care what that negative number is. I just care that I'm multiplying 3 negative numbers, and I'm going to get a negative answer. Negative times a negative is positive, times a third negative is a negative answer. So when I'm less than negative 3, it's a negative answer. In between negative 3 and negative 2 is kind of a weird one because we'd have to pick something like 2.5, right? Negative 2.5. Let's skip that one for a second, see what's going on with the other ones. In between negative 2 and 2, I could plug in 0. So let's do that. If I plug 0 in here, 0 plus 2 is positive. 0 minus 2 is a negative. 0 plus 3 is a positive. Well, a positive times a negative is a negative, and that negative times another positive is still negative. So I've got a negative there. And we're going to plug in one more big number over here. So right here, let's plug in like positive 100. Again, using those extremes, something bigger than 2. So positive 100. If I plug positive 100 here, I get 102. Positive 100 here is 98, so it's positive. And positive 100 plus 3 is positive. So I get 3 positives. A positive times positive is positive. So what I kind of want you to make a note of here, what ends up happening is in the first round, I got a negative, and a negative. And the second one that we skipped, we'll come back to that. The third one, when I plugged it in, I ended up getting a positive, a negative, and a positive. And then it was a positive, positive, positive. So you can see that one sign is changing positive every time. So in this middle one, what would have happened if we plugged in like negative 2.5 is that this would have still been negative, but this would have gone positive. So I would have had 2 negatives and a positive. In other words, what's always happening is that in this right here, it's always alternating. If this is negative, this has to be positive, negative, positive. It'll always go negative, positive, negative, positive, negative, positive, negative, positive, depending on how many key points you have. So you can actually kind of skip it. As soon as you get the first one, you know the first one's right, you could have just gone negative, positive, and had your answer. So let's actually put this into our answer though, because that's just what we need to get our final answer. Let's get that answer now. We wanted this to be greater than 0. So I needed it to be positive, meaning I'm looking for the spots that it's positive. So here is positive and here is positive. And I'm going to put parentheses or brackets. And in this case, it can't equal 0, so I know that I'm using parentheses. Had this been greater than or equal to 0 like that, then we would put brackets. But it is not, so I'm going to put a parentheses here and a parentheses here. So my final answer is -3 to -2, both in parentheses, union parentheses 2 to infinity as my answer. 39 says, suppose this is not a complete graph of the polynomial function. Instead, the function also has a local minimum at x equals 2. What might be true about the function? So if it has a local minimum at 2, that means when it gets down to 2, it's gonna turn. The only way for it to have a minimum is for it to make that turn right there. So it is gonna turn and head back up when it gets to 2. Well, what this tells me then is, could it be third degree? Well, no, this side's going up and this side's going up. So it can't be third degree because it's an even function. If they're going the same direction, it's even. So this doesn't work. Again, it could be third degree. Nope, it's supposed to be even. So I know it has to be C or D because it says it's a fourth degree polynomial potentially, which makes sense because they're both going the same direction. And then the other thing it asks us is it a positive or a negative leading coefficient? Well, all we have to look there is it going up or down on the right? It's going up, so it is a positive leading coefficient. So C is the answer we would want to pick there. Based on the behavior we see in the scatter plot, what might be a polynomial model to try to fit this data? And you can see that they've got all these factored versions. So that actually kind of makes our life a little easy. This right here represents x equaling 0. This represents x equaling 4. And this represents x equaling 7. So I can see that there's 3 x-intercepts. And so I can write those as linear factors. Remember that let's start with these ones over here, the 4 and the 7. They're a little bit easier. This would be written as x minus 4. You'd subtract the 4 and you'd get x minus 4. Here I got x minus 7. And out here I've got this little 0, so it's just x. The other thing that I can see is if I were to start connecting this, when it gets to the 0, it bounces. So this needs to have a multiplicity that's even, so it can be x squared or x to the 4th or x to the 6th, but it needs a multiplicity that is more than just an odd number. Over here, though, it crosses the x-axis and crosses the x-axis. So both this x minus 4 and this x minus 7 should have a multiplicity that's odd. So it could just stay x minus 4 and x minus 7 because then it has an exponent of 1. But it could also be x minus 4 cubed or x minus 7 to the 5th power, just something that's odd. So let's see. Looking at this first one, well, immediately I can eliminate this because that has an odd multiplicity, so it should have crossed the x-axis, and it didn't. It was tangent. These all three work, though, because I've got an exponent of 2, an exponent of 4, and an exponent of 2. So those are good. But this one definitely doesn't because all it has was that. There's nothing else here. We're missing the x minus 4 and the x minus 7, so that's not going to be a good answer. Which leaves us 2 more choices. They both kind of look similar, except this one is a positive, while this one has a negative sign. And we do see that it is going down on the right-hand side, so we need it to be negative, meaning D is going to be the choice we want. Over here it says, what is the equation of a horizontal asymptote for? X minus 1 over x squared minus 4x. Remember our rules for our horizontal asymptote. If the top number is bigger than the bottom number, or the denominator, there is none. If the top's bigger, there's none. If the top number is smaller, the top exponent is smaller than the bottom exponent is bigger, then it's y equals 0. And if the top is equal to the bottom's exponent, then we know that we take them and we do the division, right? We divide the leading coefficient by the leading coefficient of both of them. In this case, it looks like I've got a 1 on top and a 2 on the bottom, so the bottom is definitely the bigger, so that is going to be this one here. The bottom number is bigger, the denominator has a higher power, so we want y equals 0 for our answer. Make sure you don't pick this x equals 0, right? The x equals for our vertical asymptotes, not our horizontal asymptote. This one says sketch a graph without a calculator. Let's see what we can do. So we need to factor this out. So in this top part, it looks like they both have an x in common. So I'm going to factor out the x, and I get x plus 1. And in that denominator, I got x squared minus 2x minus 3. So I need two numbers that multiply to make negative 3, but add up to make negative 2. Well, the only things that multiply to make negative 3 is negative 3 and 1, or 3 and negative 1. But I want it to be negative 3. So negative 3 and positive 1. We got some canceling here. So let's pull out what's important here. So the first thing I need to care about is, what is my vertical asymptote? Remember, that comes from looking at the denominator. So this represents my vertical asymptote. In this case, it's going to be x equals positive 3. So my vertical asymptote is x equals 3. Maybe I should have used a colon there. There we go. My horizontal asymptote, that is based off of the rules. So we look at our exponents. In this case, our exponents were the same. So we're going to divide those leading coefficients. So 1 divided by 1, that's just going to give us 1. So I know that there is a horizontal asymptote at y equals 1. For my x-intercepts involve us looking at the top of the simplified version. So what would make that top part equal 0? Well, it's just x, so 0. So it looks like the x-intercept is at 0, 0, because that's what would make the numerator equal 0, is 0. Y-intercepts, we want to look at the unsimplified version. So look at the unsimplified version, and we take the constants and make them into a fraction. In this case, there is no constant on top. It's 0. So my y-intercept would be 0 over negative 3. But as soon as 0 is on top, we know that we're going to end up with 0, which makes sense. If the x-intercept's y 0, 0, then the y-intercept also has to be y 0, 0, because they're both crossing those same axes. One more important thing we want to determine is, what is the hole on the graph? Or remember, we could call that the removable discontinuity. In this case, I canceled out that x plus 1, so what I know is that negative 1 is going to have a hole in it. And I need to plug that negative 1 back into this problem. So I plug negative 1 on top. On the bottom, I got negative 1 minus 3. And I end up with negative 1 over negative 4, which is just 1/4. So I have a hole at negative 1, 1/4. And that should be enough to get our graph going. So let's start with these asymptotes. I got a vertical asymptote at 3. I had a horizontal asymptote at positive 1. I have my x and y-intercept both at 0, 0. And I have a hole at negative 1, 1/4. So I can see pretty quickly that the right side of my graph is going to look like this, because it's got to go through those 2 points. Now, I don't really have anything happening on the right side. I need to figure out what's going on over here on the right side of that asymptote. So we need to plug something in. So maybe let's plug in, I don't know, let's choose 4. So I'm going to plug in 4. So if I plug in 4, I got 4 on the top. On the bottom, I got 4 minus 3. That's going to give me 4 over 1. So when I plug in 4, I get 4. So what I know is that there's going to be a point somewhere up here on this part. So my other part of my graph should look like that, so that it goes towards those 2 asymptotes. And that would be our sketch. 43 says, which of the following best describes the graph? The graph has a removable discontinuity, or a hole, at x equals 3. Well, I think we need to factor out to figure that out. So let's do that. We're going to have to factor by grouping here, because I've got this 2 in front. So let's split that middle term. So I need to multiply 2 by negative 3, and I get negative 6. So I need 2 numbers that would multiply to make negative 6, but add up to make negative 5. Well, I think that's going to be negative 6. It's going to have to be negative 6x plus 1, right? Negative 6 times 1x would give us negative 6, but then negative 6 plus 1x is going to give us negative 5x. And we can go ahead and factor this by grouping now and see what we get. So I'm going to factor out a 2x here, and I get x minus 3. Over here, I can't factor anything out, so I'm going to put a plus 1 outside, and I get x minus 3. So I know that this is going to overall factor. The top number is 3x over x minus 3. I just kept the numerator from here. And then in the denominator, I'm going to have x minus 3 and 2x plus 1. So I can see these cancel. So there is a removable discontinuity at x equals 3, but we need to see if that means that there is a vertical asymptote at negative 1/2. There would be, right? that might be the answer. Interesting. Because the vertical asymptote, right, our vertical asymptotes come from this denominator here. So it might be the first one. -1/2 is right here. Let's double check. The graph has a vertical asymptote at x equals 3. No, it has a removable discontinuity at x equals 3, so it's definitely not B. The graph has a removable discontinuity at x equals 3 and x equals -1/2. No, only at x equals 3. The -1/2 is the asymptote. The graph has a vertical asymptote at x equals 3. No, still not the answer. So it is the first one, A. There is a hole at 3 where we canceled our thing out, and there's a vertical asymptote when we set that equal to 0. -1, and then divide by 2 is -1/2. All right, this second page, number 44, says, evaluate each of the following without using a calculator. So we should be breaking out that unit circle and using that unit circle that you hopefully have written at the very beginning of your test. The first thing I want you to do is you're going to take your scratch paper and write out a unit circle before you even start this test. But using this, I don't have a unit circle right here, so you're going to have to trust that I'm looking at it or using the hand trick, whatever makes sense to you. So for cosine of 7 pi over 6, well, I know that things at 7 pi over 6 are square root of 3 over 2 and 1/2. And 7 pi over 6 is in the third quadrant, so both of them would be negative. And we know that cosine is represented by the x value. So in this case, it is going to be negative square root of 3 over 2 for our answer. Sine of 135, this is going to be represented by the point. I'm just going to kind of write it back next to it like this. We'll keep doing it with the same colors though. So sine of 135, that's going to be square root of 2 over 2 and square root of 2 over 2. Anything that ends with 5 is going to be. And it's in quadrant 2, so the x is negative. In this case though, since we're talking about sine, we're focused on the y value. So it seems to me we're going to get square root of 2 over 2 as our answer. Next one is tangent of 3.
Teachers, please pardon this interruption. Just a quick announcement this morning because we don't have a second period class. If you look on Teams, there's instructions to do a Google form, Microsoft form, for students that are absent. So we can do that for official attendance. So please look on Teams for that Google form. It's supposed to be taken at 10 a.m. for official attendance. Thank you so much.
So I kind of jumped ahead. Sorry about that interruption. I kind of jumped ahead a little bit here, just put some things. We know that tangent 315 is also a square root of 2 square root of 2 situation. So what I know is that's in quadrant 4, and in quadrant 4, the x is positive, but the y is negative. And for tangent is y over x. And remember we said that you can disregard the denominator. Since these both have the denominator of 2, they're going to cancel. So I'm just going to take the numerators and divide them. Negative square root of 2 divided by the square root of 2. Well, if you take anything and divide it by itself, you get 1. So negative square root of 2 divided by square root of 2 is going to be 1. Likewise, 5 pi over 4 is another one of those pi over 4s, and we know it's going to be square root of 2 over 2 and square root of 2 over 2 for my x and my y. And we know that 5 pi over 4, since the number on top is 1 bigger, it's in quadrant 3. So we're going to have double negative here, negative x, negative y. Secant is reciprocal of cosine. That didn't stay, that didn't write. 1 over cosine. So since it's the reciprocal of cosine, I know that my focus needs to be on the x. Specifically, I need to take the reciprocal of x. So I'm going to take that x value and flip it upside down. Negative 2 over the square root of 2. So I just put the numerator on the bottom, the denominator on the top. And now I need to rationalize it because we can't have a square root in the bottom. So I'm going to multiply square root of 2 to the top and the bottom. The top, negative 2 times the square root of 2 is negative 2 square root of 2. And the bottom, square root of 2 times square root of 2 is 2. Those 2's cancel. And I end up overall with an answer of negative square root of 2 as my final. And for this last one, we got another secant. So again, we're focused on cosine. Now, negative 3 pi over 2, think about that. If we go here, 3 pi over 2 is normally here, but we're going negative. So it's going to be negative pi over 2, negative 1 pi, negative 3 pi over 2. So we end up at this top number, which is 0, 1. So we're focused on 0, 1. Well, cosine, again, is the reciprocal of x. So I have 0 over 1. If we want to write that as a fraction, we're going to write it 0 over 1. So when I do my reciprocal, my 1 moves on top, my 0 moves on the bottom, and as soon as you get 0 on the bottom, we know that this is undefined. Very important that if you take the reciprocal of 0, you do not get 0, you get undefined. So keep that in mind as you're working through this. 45 says draw the angle in standard position negative 2 pi over 3. So we know that we're doing negative 2 pi over 3, we're going the other direction. And it asks us to label some things, so we'll come to that in a second. This is my starting point, my initial ray. Actually, let's kind of just do this as we go. This is the initial side. So that is part A, initial side. Next thing is the terminal side. Well, 2 pi over 3 normally is up here, but we are not going that direction. We're going negative 2 pi over 3. So instead of it being in quadrant 2, it's going to end up in quadrant 3. So like here. Doop, 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 doop. Just like that. And we'll call that B, the terminal side. Again, because it's going negative, it ends up being on the bottom of the graph instead of the top. And they want us to put the direction of the rotation. So the direction was that we went in the negative direction. So here's C, direction. D asked us the quadrant or the axis where the angle terminates. So we know it terminates in quadrant 3 for this one because it's going negative. And the exact value of the point at the angle of rotation on the unit circle. So they want us to figure out what point that would be right here. Now, at first that might seem like, wait, how can I do that? If you know you're in a circle, you got this. Look at negative 2 pi over 3 on that unit circle, or look at that spot, which really wouldn't even be 2 pi over 3. It would probably be on your circle as 4 pi over 3. So if you look at 4 pi over 3 on your unit circle, you would know that this is negative 1/2 and negative square root of 3 over 2. And that would be the answer they want here, negative 1/2 negative square root of 3 over 2. Again, that just came straight from the unit circle. If you have it memorized and you've written on scratch paper, you'd be able to find the answer pretty easily. Which angle is not, which angle of rotation is not coterminal with 30 degrees? So to find coterminal, remember, it's just adding or subtracting 30. So I've got this 30. I'm going to start by adding 360, and I get 390. So we know that this one is coterminal. Looks like they added 360 again, maybe to get to this 750. Let's try it. Add 360 again. This is non-calculator, so I'm writing it all out. So 9 plus 6 is 15. 6 and 7, I got 750. So that looks like it works. That's a good one. And to get to these negative ones, we're going to have to subtract. So 30 minus 360 is going to give us negative 330. So this one's good. And I guess that makes sense. Negative 30 is 60 units away from 30 degrees. So it definitely isn't coterminal because we can't do a full 360. So that would be our answer there. 47 says, given the point P, negative 512 on the terminal side, find the exact value of each of the following. So we need to draw this graph here. So I've got negative 5, 12 being graphed, so left 5, up 12, somewhere like that. Remember, it's not super important as long as we got a graph that's in the right quadrant. Because we're going to create this right triangle, go straight down to the x-axis, and then go over to the origin of the graph. And I know that since I went left 5, this represents our negative 5. I went up 12, this represents our 12. And we need to figure out what this long side is going to be. Some of you may know that already, but if not, let's plug this into the Pythagorean theorem and see. Some of you may have learned your Pythagorean triples, and you could do that right away. But if not, 25, again, this is non-calculator, so you want to make sure you're trying it without it. If I add those together, I get 169, and if you take the square root of 169, you get 13. So this should be 13. In other words, it's a 5, 12, 13 triangle. It's a special right triangle. So they asked us to find the sine, cosine, and tangent of theta. Remember, theta is always by the origin. So you could do it a couple ways. You could think about it like our formulas where we did cosine is x over r, sine is y over r, and tangent is x over y. That's not right. It's y over x. Don't do that. Y over x. So you could just use that if you wanted to. So cosine is x over r, so negative 5 over 13. You can see that because also adjacent over hypotenuse. If you remember SOHCAHTOA, that works too here. It is adjacent over hypotenuse as well. Tangent is opposite over hypotenuse, or y over r, so it's going to be 12 over 13. And lastly is tangent. Tangent is opposite over adjacent, or y over x, so it's 12 over negative 5. Make sure if those could simplify, you did simplify. But in this case, since that 13 is there, it's not going to simplify. 13 and the 5, they're both prime, so it doesn't simplify. Given this trig function, identify the amplitude. the horizontal and vertical shifts, and the period. So the first thing I'm looking at is this amplitude. Remember, that comes from the front here, and it's always the positive number. If it was negative, you keep the positive. In this case, it is positive, so we don't have to worry about it. So keep that in mind. In this case, amplitude is 7. The horizontal or vertical shifts, well, vertically we see that it is going -2. This represents down 2. My left and right, my horizontal, there's nothing inside the parentheses being added or subtracted, so there is no horizontal shift or phase shift. So all we have is down 2 units. And for the period, that's where we're going to take sine is 2 pi over b. Remember, sine and cosine is 2 pi over b, but tangent is 1 pi over b. And we can see that right here, b is 4. So I'm going to take 2 pi divided by 4. That's an ugly b. Try that again. 2 pi over 4. The 2 and the 4 both divide by 2. And I end up with pi over 2. 49 says, what is the range of the trig function? Remember, range is the y value. And at first, this might seem like, wait a minute, can I do this? Is this doable? Yeah, this is so simple. They did ask for an interval and set notation, though. So I'm going to draw just a really rough sketch over here. I'm not looking for anything super accurate. But what I care about is the fact that sine has been shifted. This function has been shifted down 1. So my midline is here at -1. Meaning, if my amplitude is 3, then my maximum and my minimum can be found again by taking the amplitude and subtracting. Sorry, it's not that. It's take the midline and subtract, right? Take the midline, which we know is -1, and add 3. And take the midline and subtract 3. So -1 plus 3 is going to put us at +2. And -1 minus 3 is going to put us at -4. And ultimately, all I care about here is the fact that it's going to start at its midline and it's going to go up and down and up and down and up and down, meaning it's going to have a maximum of 2 and a minimum of -4, and that is the range of the function. So in interval notation, we know the range is that it can be -4 to 2, and it can equal those, so we're going to put it in brackets. And for set notation, we're going to write y such that, since it's range, we're putting y. We know that y is a value between -4 and 2, so I'm going to put y such that -4 is less than or equal to y, which is less than or equal to 2, and that would be your set notation for this range. This one says, what is the phase shift of the function? They made this so easy. First thing we always look at is, do I need to factor anything out from in front of this x? If there is a number in front of x, you must factor it first. That has to be step 1. But since there is nothing in front of x here, you don't got to factor anything out. It's done for you. So all I care about is the fact that this here represents our phase shift, -pi/4. So that negative is backwards. So instead of being negative direction, it's to the right. Pi/4, oh, come on, stop. Pi/4 units. Let's do this. That said, right? Pi/4 units. That's better. That's what I was trying to write. All right, we are on this last page. We're done. We're so close. All right, find the period, the phase shift, the period and the phase shift of the given function. Again, they already factored the 3/4 out for you. How lucky are you? They've already done it. So I know that this right here means we're going left pi/4 units. So I can know that this one's right and this one's right. So we can eliminate B and D. This one's pi/4 to the left and pi/4 to the left. So those A and C are the only two answers that would make sense. And in this case, B is 3 pi/4. So we know to find the period, we're going to take 2 pi divided by B. In this case, we're going to end up with 2 pi divided by this fraction, 3/4. So we're going to need to keep, change, flip. Keep the 2 pi. In fact, I'm going to write it as 2 pi over 1 so I can multiply it by the fraction we're going to get. And we reciprocal. Take the reciprocal of 3/4, so 4 over 3. And 2 pi times 4 is 8 pi. 1 times 3 is 3. That doesn't simplify, so 8 pi over 3. So A is going to be the answer we want. Period of 8 pi over 3. And a phase shift pi over 4 units to the left. This one says, what is the equation for the graph shown below? Note that the graph increases in increments of pi over 2. So what I first need to acknowledge is it a sine or a cosine curve? And it starts at the origin, so I know that this represents sine, which you can see all of our answers in sine. So that's a good thing to note. You can see all of them also have an amplitude of 2, which makes sense because it does have an amplitude for its minimum maximum at 2, so we're good there. What I care about is how long does it take to finish one full rotation. So it goes up to its maximum, back to the midline, down to its minimum, and over here it finishes one rotation. So pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and a half. So 6.5 pi or 6.5 pi. So if I was going to write that as a fraction, that's going to be a little bit weird, but 6.5, we need to write that as a fraction. 6.5 pi, we don't want it like that. We want to get that set up a little bit differently. Actually, let's worry about how we get there, right? We need to figure out what b is. So 2 pi over b equals 6.5 pi. That's about what we have set up. So let's solve this equation. The first thing I have is this issue right here. I can't have b in the denominator. I cannot have that. So I'm gonna multiply both sides by b, which puts us in a little bit better spot. 2 pi plus 6.5 pi times b. We can then go ahead and divide both sides by 6.5 pi, 6.5 pi. These pi's cancel and these 6.5's cancel, these pi's cancel. So overall, what I know is b is going to equal 2 divided by 6.5. So maybe we can figure out what that is. In fact, I think the easiest way to get to that answer, I took us on a journey, didn't I? Yeah, because I screwed that up. Hi. Hello, I'm Mr. Nakarado. I'm your teacher that likes to make things difficult. Delete. This isn't 6.5 pi. 2 units is 1 pi. 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. This is 7 pi. Oh boy, 7 pi. This is going to make this a little bit easier. 2 pi over, it's like this is not a non-calculator question. What is happening? 2 pi over b is 7 pi. Same thing, multiply b to both sides. Cancels here. And I get 2 pi equals 7 pi times, I don't want 7 pi times pi. I want 7 pi times b. There we go. 7 pi times b. And then we divide both sides by 7 pi and 7 pi. That cancels over here. On this side, the pi's cancel, and I can see that 2/7 is equal to b, so we're going to want to pick answer choice C. 53 says, what is the definition of a radian? So remember, a radian is the length, sorry, not the length, the measure of a central angle, which we refer to as theta, when the length of the intercepted arc.
Good morning, teachers. Just a reminder that today, this morning, attendance, because we don't have a second period class today, there's a Google form that you need to complete at 10 a.m. for attendance, and that identifies absent students for our daily attendance. Thank you so much. Please, again, check on Teams for that Google form that you need to complete at 10 a.m. for absent students. Thanks so much.
This is why I don't record videos in the morning. This is it. So the length of the intercepted arc is equal to the circle's radius. So for example, if the radius is r, then the radian is this angle measure right there. So that if this is r, this is the radius, this is the same length. So that's a radian. With that, it says, can we convert 1 radian into degrees? Absolutely. 1 radian. And it asks us to keep our answer in terms of pi. So 1 radian. And to convert to degrees, we have to multiply by 180 degrees and divide by pi radians. So in this case, what's going to end up happening is 1 times 180 is 180 degrees. And then in the bottom, we have pi radians. So our answer would just be 180 divided by pi. That would be the form in terms of pi. Since they want us to keep it in terms of pi, we're not actually going to divide by pi. So we would just leave it like that. Pi 180 over pi. Hopefully that helps y'all. Let me know if you need anything.